Hello, this is Garrett Keane, continuing the series of videos in programming in Microsoft Excel, Visual Basic for applications for engineers. In this example, we have to design a short application that will work out the hydrostatic resultant pressure force acting on a submerged plate, and also the depth from the surface to the center of pressure. That's where this resultant force actually acts. There's a couple of input parameters which we need for our program. They're shown here in this frame, which is for the input values. We need the width of the plate, which is actually into the paper there. We need the height of the plate, which is this distance from here to here. We need y bar, which is distance from the surface down to the center of gravity of the plate. Normally with a rectangular plate, the center of gravity is going to be in the center of the plate. We also need to know the angle phi at which the plate is inclined relative to the surface. Then we have a button to calculate, and you can see here that I name these controls. We have text B here. Although it says width here, we use the symbol B, and I'll show why in a second. Also for the height, we have text D. For the y bar, which is the distance from the surface of the water down to the centroid, the center of gravity, we call that text y bar. And for the angle here, we have text phi. So basically we have 4 labels here, and we have 4 text boxes for the input. You'll see that actually how the program works in the sequence of calculations. It needs first of all to work out the area using the standard formula A is equal to B times D, and that's why I call this one B for the width of the plate into the page. And D is the length of the plate, which is the height of the plate in this case, from here from Q down to P. Then for this, we also need to work out the second moment of area, and the equation for that is IG is equal to BD cubed over 12. There's actually an error here, it says squared. In fact, it's BD cubed over 12. Then to work out, so we need to come up to Developer. On here, Visual Basic, Insert User Form, so we get a blank form here. I'll just stretch it out a bit, and the first thing we're going to do is put in the image. So I put a box here, I click on Image, which is this control down here on the toolbox. Remember, if your toolbox disappears, come up to View Toolbox and you'll see it. That turns it off, that turns it on, and that applies for the Project Explorer here and the Properties window also. Then you can see here when I click on Image, it's an image object and it has a series of properties, but the one you come to here is Picture. Now I have mine on the C drive. I have this image on the C drive, but you may have it somewhere else on your system, such as your Z drive. So I have it under here on C, Images. If I can find it, here it is, Image. I open that directory and I have the image file submerged plate here, and you can see it brings it in there, and I might just expand it a little bigger and down further. So I expand it so it fits in, maybe narrow it a bit and down. So I'm resizing it until it actually is the right size, basically. That will do. And then the next thing I need to do is a frame for the input value, so I put that over here somewhere, and I'll call it F4A, that's the short 3-letter prefix for a frame, input values. Spelled it wrong there, so input values. And on the caption here, I put input values. Okay. Now I'm also going to have a frame for the results, so I click that in and put it in straight away. I'll come back to it after. So I go Frame, Results, and I'll just put here Results. So I click back in here and I'm going to start adding the controls. So the first control is my width. I don't need to give this label a name because I'm not going to manipulate it later in code. So now in the form it says width, but I'm going to actually put a bit more in here. And I'm going to say width of plate meters. shorten that, narrow it a little bit, and I'm just giving a bit more information than is actually given in the specification for the project. If I come here, I also make it right aligned. So if you come to text align, I come to form align, and I make it right aligned. You'll see what difference that makes. I'll just widen that a little bit. Then we come here and I put a text box in there, and maybe that's a little big, just a little smaller. That's fine. That's a good one there. And I put that text box there, and I click it like so. Now the next label is what I call this one. I'll put the caption on this. I don't need to call it because I'm not going to make height, length of gate, and also in meters. And it's important to tell the user of your program and make sure it's right aligned. It's important to tell the user of your program what units to use. Now instead of creating a new text box, I'm going to just move this one down a little bit. I can just copy this by selecting it, edit, copy, click in here, make sure you're clicked in there, edit, paste. There we have our second text box, and I move it in like so. Okay, then the next thing we need to do is put the next label in, and this is Y bar. Distance to centroid. And once again, that's the distance in the surface to the centroid. And I might even put in distance from surface, just to make it a bit clearer, because there's room for distance from surface to centroid. Widen it a little bit. I might just widen the whole thing, because it's the more detail you have in there, the better. So I'm widening everything. I'm just going to rearrange everything to get it all to fit. Move this guy over here, move this label over here. And once again I move this here. And to make it fit, to make it all aligned, these labels aligned, I'll come down and make this right aligned. So the text is right aligned within the text box. And then I click here, I do edit, copy, click in here, edit, paste, and I have the next text box for input. I might just, these are looking a little bit cluttered, so I'll just realign them. And then the last one is the angle phi. So I put a label in here and I say inclined angle phi, and tell the user to put it in degrees. I'll just stretch it out like that so it all fits in. And then I come here and I go edit, copy, edit, paste. I can bring it down like so. Now if you look at these, they're not all evenly spread, so I'll just bring that one up a little bit. Takes a little bit of judgment just to get them aligned. Like so, that looks a little bit better. Bring that up. You bring this label up, and I can bring this in there, and that looks a good bit better now. Once again, you can see here this isn't aligned, but if I come here and make it right aligned, it's now aligned correctly. So you can see there, that's our input frame is done. I have to name it. So as I said in the handout, we'll call this one text B for breadth. Text D, and I'm calling it D because that's the formula that's going to be used in the formula A is equal to B times D. I call this one text Y bar, and I call this one text phi, like so. So that is our input frame completed, and then we can come down here and we look after our output frame. Now, for the output frame, we need the, if we go back to our spreadsheet, it tells us what we need exactly. We need the frame for area, a text box for the area, for the second moment of area, for the resultant ore, and for the depth to the center of pressure D. So if I start doing these ones, go back to the Visual Basic. So area of plate. And you can see here I'm putting in a bit more information than is actually asked for in the form. But when you're designing an application, you should try and make it as clear as possible. So if you notice here, I do area plate like that. I'm going to make it right aligned. Now there's no superscript in the text. So what I have to do is come to my text, my label. And if you come to font here, to home and arrow, the font at the moment is in 8. So I'm just going to write in 6. I'm going to write in 2 here, create a label with 2 in it. Now it's very long-winded, but and I'm going to, if we come here to edit, copy, I can take this little fella here, edit, sorry, just bear with me here, put a little window around that, and I size it in like that, and I bring it up here, and that's the only way I can get it squared in there. It's very messy, but that's the way I can get it to work. So it's meters squared. It's not great, but it's one of the few ways you can actually get it to work properly here. Then the next thing I want to do, I want to keep the text box the same size, so I copy this one, go edit, copy, and then I click back in here, and I go edit, paste, and I bring it up like so. Now unfortunately, when I change the font, it's changed the font here, so I better come back here to this and change it back to 8 here. You can see it's gone, the results is back to 8. So area plate is meters squared. The next label is second moment of area, IG. If I come to the caption, and it's meters to the power of 4. So I do this first of all like so. Copy this guy, edit, copy, edit, paste. Now I have my second box there. I bring it down like so. And once again I need to do a little 4 here. So because second moment of area, the units are meters to the power of 4. So once again I start a new text box, a new label here. I click in there, but I come down to the font and I size the font a bit lower at 6. Okay, and then I come in here and I write the letter 4, and that's my label done. I take this guy, I resize that window down to a very small size, that's too small, and then I just move it while I have it there. And you can see there that it's not great because it's knocking out it's kind of covering over the M, but it needs a bit of work basically. Then the next thing is I'll come back to that later, but you can work on that yourself to tidy it up a bit. The next thing is our resultant force. And that's ore, and of course that's in newtons, capital N for newtons, and we may have to switch that to kilonewtons, we'll see in a minute. I come down here and I make sure it's aligned on the right hand side. Same with this guy here. Now I may need to move the label. No, it didn't make much of a difference. What I'm going to do is just move him off to the right a little bit if we can select it. It's very fidgety, but I can move it off to the right up there, and you can see it's there, meter to the power of 4. So the last thing, oh sorry, I need another text box here. Edit, copy, edit, paste. That's the text box of the resultant force. And then I need the label for the depth to center of pressure, so I'll map it out here. Caption, depth to center of pressure, D, capital D, and that's unit is just meters. So if I widen a little bit, will it all fit in? I might be running out of space here. I'll text align it to the right hand side, see if we can squeeze it in. I'm going to paste the last text box in. I'm going to bring it down a bit. They look like they're all evenly spaced. I'm just going to widen it a little bit. This one a little bit. If I want to move everything over, I can just map out a little window here. And then I have them all selected and I can just move them all over in one go. Do the same here, map out a rectangle around all of them. See the way it's selected, and I can move them all in one go. And these in line up here. You can see if they're in line. There's a bit of work here, but I'm trying to make sure that the frames are lined up. I think that's a little bit big, but okay, it's there anyway. I can tidy it up later. Now, if you notice this, our window isn't big enough, so I need to come down here. I need to select this frame here by clicking on it, just the frame. You can see the broken line comes on the outside, and I move it down because, of course, I forgot to put the command button in, and the command button is here. I select the command button here, and I have to call this btn calculate, and the label is calculate or and D. Now I've made it quite wide there. I can just shorten it down and center it in the middle. Okay, and of course what I forgot to do here was to come in here and name these text boxes, which we're going to have to name because they're going to be used in the code. So if I go back to my spreadsheet, text area, text IG, text OR, and text decop. They're the names that we have to give. Yeah, name that one. So I said we're going to call this one text area. I could have just said text A. Call this one text IG. Call this one text OR. And call this one text D and COP for center of pressure. Not to confuse it with the D up here, which is the length of the gate. Now if I come up here, I'm just looking at this, with the plate, and really I should put in the symbol here, so with the plate we call B. That's what's going to be used in the calculations. The length of the gate, right here, what we actually use in the formula is D. So I'll put that in like that, and it's in meters, so I'm putting in the symbol that's going to be used in the formula. Y bar, so I'm going to swap this around, just to be consistent. Distance from surface to centroid, and that we call Y bar, and the units are meters, and the inclined angle phi is in degrees. The area of the plate is meters square. I need a bit of work to tidy that up. Second moment of area is IG, and it's meters to the power of 4. The resultant force OR is in newtons, and the depth to the center pressure D is in meters. So that is our form finished. So the next thing we need to do is add code to that. The only other thing I'd say is here on the user form, I haven't given the user form a name, but I can put in a label across the top, or a caption across the top of the user form. Calculation of hydrostatic forces on on a submerged plate. So it's a description of what the actual program actually does on a submerged plate, let that in capitals. So that's it finished, and now the next video will show how to actually code it up so that when the user puts in these parameters here, these values here, it will calculate the area, second moment of area, resultant force or depth, the depth of the center pressure D here. Okay, thank you for listening, and you can move on to the next video to actually start putting the Visual Basic code in. The resultant pressure force that acts on the plate, that's due to all the water above the plate, or is equal to rho g a y bar. Rho is the density of the fluid, which in this case is water. G is gravity. A is the cross-sectional area of the plate, which we worked out here. And y bar is the distance, as we said already, from the surface down to the centroid. This kind of makes sense that as y bar gets bigger, that means the plate is further down, there's more water above it, and therefore the resultant pressure is greater. Now, where does that resultant force act? Well, it acts below the centre of gravity at some point here, and it's given by this formula: D is equal to y bar plus Ig, the second moment of area, divided by the area multiplied by y bar over sine phi squared, where phi is this angle here. So you can see there that I have the button here, in which we're going to code up these equations. And then we have our output frame, which I've labeled here results. And here we're going to put out the area, so I'll call it text area. We're going to put out the second moment of area, so I call it text IG. We're going to put out the resultant, I call it text OR. And the depth to the center of pressure, this is known as the center of pressure, point C. And that's text D COP, COP being short for center of pressure. So the first thing we'll do is we'll design this form.